Hi there. This video is an update to the original Catenary video. The original video calculated the fixing height using the Cosh hyperbolic function, given a known ground clearance and given a desired fixing width. How do we calculate the necessary fixing height to match the ground clearance and the width of the cable suspension? So a catenary hangs under its own weight. It's defined by a hyperbolic cosine function. This function is an exponential series. Exponential Euler's number. Why is Euler's number important? This is a natural process because it's hanging under gravity. So what we want to do is to rearrange this equation here. So how do we do that? So what we're doing is, if we've got a desired ground clearance, we've got a desired fixing height, how do we rearrange this equation to work out the fixing width? So what we're going to do is to take the original equation. The first thing we do is we divide both sides by c. So what we're doing here, the posh word is transposition of equations. If you do the same thing to both sides of the equation is still balanced and the equal sign is still valid. Divide both sides by c first, and we get y divided by c on the left-hand side. On the right-hand side, we get rid of this c here. Then we do the inverse Cosh function of both sides. And then what we do is multiply both sides by 2c. And what we end up with is a rearranged equation to work out the calculated width of the fixing points, given a ground clearance and given a fixing height y. If we do an example where the fixing height is 50 meters, the ground clearance is 4 meters, how do we work out the fixing width? If we plug our values into the new rearranged equation, we jump through the algebra here, we end up with 15.973 meters. If we round that off to typically in engineering terms, we use 3 significant figures, it rounds off to 16.0 meters width. We can then do the calculations in an Excel, and what we can do is plot out the U-shaped where X is the reference, X equals 0, and you've got plus and minus 8 either side, giving you the width of 16 meters. So if we go back to our Excel, what we've got is in this cell here, we've got the calculation using the rearranged formula. We then take that calculation and plug it into this column here, and what we've got down this left-hand column is, in order to plot out the U-shape, we've calculated the width in this cell here using this equation. We then have a resolution, so this column here is the width. We've got a step change in the width of 0.2, which can be altered there. So for example, we can change that resolution so that you've got a finer calculation, but then we obviously have to change the size of the plot there. So if we put it back to the original 0.2, it will plot out our U-shaped. So we've got a fixing height of 50 meters. We can see that there on the graph there, 50 meters. We've got a fixing width here of plus 8 meters, and we've got a fixing here of minus 8 meters, which are around the reference point X equals 0 gives us plus or minus 8 meters either side, 16 meters width. Thank you for watching. I hope that's been informative. Any comments, please put them below. If you would like to subscribe, please do that as well. Thank you.